morning, students. This is Anjali, Assistant Professor, Department of CAC, AIML, IARE, Hyderabad. Today's our topic name is Problem Solving on Set Theory. Guys, you know about the set theory very well, but still we will learn just basic things about the set theory. What is meant by set? Just we can say the set is the group, or we can say set theory has its own notations and the symbols that can seem unusual for many. That means we can say just set means it's a group and the data will be in the group format. The set is a collection of the object. So definitely we can say it is usually represented in curly braces, or we can say we have to represent in the flower braces. Now we can take some example like set of the natural numbers. Natural number means just we can start from 1, 2, 3, 4 up to n. Then we can take another example that is whole numbers. That whole numbers means it will start with the 0 and it will end at the n. That means these are the set of the natural numbers and the set of the whole numbers. So each object is called as an element of the set. That means these numbers are your elements which are present in your set. Now, the set that contains all the elements of given collection, that is called a universal set. And it is represented by the symbol mu. So, the elements will be available in the collection, so that will be the universal set, and that universal set we can represent by using the mu. Now let's consider two sets, set A and the set B. Now n of A union B, that means the number of elements present in either set of the A or set of the B. Then next one is that n of A intersection B, that is represent the number of elements present in the both sets A and B. In A union B we can say either the elements are present in the set A or set B, or A intersection B is showing that elements are present in both sets A and B. Now for that there is one formula also, that is n of A union B is equal to n of A plus n of B minus n of A intersection B. But this formula we can use only when you have only two sets. For two sets we can use this formula, but now if you have three sets, then which formula you have to use? So again there is another formula, that is n of A union B union C, that is n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So these two formulas are very useful. This formula you can use only when you have two sets available, and this formula you have to use when you have three sets available. Now we will move to our examples. Now first example is that in a class of 100 students, 35 like science and 45 like maths and 10 like both. Now, how many like either of them and how many like neither? You have number of students 100, 35 students like the science, 45 students like the maths and 10 students like both science and maths. Now we will see the solution. Now we have total number of students. So total number of students we can show by using the n of mu. That n of mu is your 100. Then number of science students who like the science, that is we are denoting by using the n of s. Numbers are 35. Then number of math students, like we can see who like the math, those students n of m is 45. Now number of students who like both n of m intersection s, that is 10. Now number of students who like either of them, that means we can say any one subject. So for this you have a formula n of m of intersection s is equal to n of m plus n of s minus n of m intersection s. This formula you have to use. Now you have total number of students, number of science, total number of maths who like the maths and the intersection of both maths and students. Now you have to keep all the values in your formula and you will get the particular answer. So n of s is 35, n of m is 45 and minus 10 means n of m intersection s, that is 10. You have to find out this value. We got the 70. Now number of students who like neither. So definitely who doesn't like any one subject, we have to find out. So there is a formula, that is total number of students minus who like either maths or science. So total number of students we have 100 minus who like any one of the subject, that value is 70, and after solving this you got 30. That means 30 students are there who doesn't like any of the subject. So even this formula, this problem you can solve by using the Venn diagram also. So this is your Venn diagram. This is showing for the maths 45. This is showing for the science 35. Total number of students is 100. From there, who like both subjects, maths and science, those are 10. Only who like 45, those are 45 who like science, that number is 35, and who like both the subjects, science and maths, that is the 10. So by using this, you can get your values. You can get your answer. Now second example is that there are 30 students in the class. Among them, 8 students are learning both English and French. A total of 18 students are learning English. If every student is learning at least one language, how many students are learning French in total? Now by using the Venn diagram, we can find out all the value. English, who are learning English, that number is 18. Who is learning English and French, that number is 8. And now we have to find out the French, who are learning the French, and total number of students is 30. Now actually in this example we got to know that every student is learning at least one language. So there is no one who fall in the category like neither. So we can say that in this case, for English we can denote E, and for French we will denote F. So now number of English Union French. That means this is showing that or condition. Or condition either learning English or French. So that number is n of mu. And we can say that n of mu means that is 30. So here 18 students are there who are learning English and 8 are learning both languages. That means we can say 18 minus 8, that is 10, who are learning only English. And now we got the number for the English. That means n of mu is equal to 30, n of E is equal to 10. Now you have to find out the value. Again you know the formula. If you have two sets, then which formula you have to use, you know. So n of E union F is equal to n of E plus n of F minus n of E intersection F. E union F, this value you have, that is 30. Then n of E, this value is 18. N of F we have to find out, and n of E intersection F, that is 8. By solving you will get the value n of F, that is 20. That means total number of students learning French, that is 20 number. So by using this, total number of students who are learning French, that is 20. But already out of 20, 8 students are in common. 8 students are learning English also and French also. So definitely only 20 minus 8, that is 12 students who are learning only English, only French. But here it's asking total number of students learning French. They didn't use any only word. So our answer will be 20. Now next question is, among a group of students, 50 played cricket, 50 played hockey and 40 played volleyball. Now 15 played both cricket and hockey, 20 played both hockey and volleyball, and 15 played cricket and volleyball, and 10 played all 3 games. Now keep in mind, there are 3 sets, that are cricket, hockey and volleyball. So according to this, you have to find out the answer. Now, if every student played at least one game, find the number of students and how many played only cricket, how many played only cricket, only hockey and only volleyball. Now, see, 50 students are playing cricket. So that means n of C we can say 50. Then next one is that 50 played hockey. 50 played hockey. So n of H, for hockey we will use n of H. And 40 played volleyball. N of V is equal to 40. Now they are saying 15 played both cricket and hockey. Both cricket and hockey. So N of C intersection H, that is 15. Then 20 played both hockey and volleyball. N of H intersection V, that is 20. Then next 15 played cricket and volleyball. N of C intersection V, that is 15. Now 10 played all three. N of C intersection H intersection V, that is 10. Now number of students who played at least one game. At least one game. If there is a symbol that union, so definitely it's showing the case for the either. So here N of C union H union V is equal to N of C plus N of H plus N of V minus N of C intersection H minus H intersection V minus C intersection V plus N of C intersection H intersection V. Now every value you have, N of C is 50, N of H is 50, N of V is 40. Now N of C intersection H value is 15, N of H intersection V value is 20 and the N of C intersection V, that is 15, and plus N of C intersection H intersection V, this value you have 10. Now you have to keep all these value in this formula and after solving you will get the answer 100. That means total number of students 100 who are playing at least one game. Now let's denote the number of people who play cricket and volleyball only. Then B will be denote number of people who played cricket and hockey, and the C will denote the number of people who played hockey and volleyball, and the D denote the number of people who played all three games. Now accordingly D is equal to N of C intersection H intersection V is equal to 10, and now C intersection V is equal to A plus D, that is 15, C intersection H B plus D 15, and H intersection V C plus D, that is 20. Now therefore A is equal to 15 minus 10, that is 5. Cricket and volleyball only. A is showing that who played cricket and the volleyball only. Then B is equal to 15 minus 10. It is showing for cricket and hockey only. And C 20 minus 10, that is 20. It is showing for hockey and the volleyball only. Now number of students who played only cricket, that is N of C minus A plus B plus D. All these value you have, and after solving, after keeping this value, N of C is 50, A value is 5, B value is 5 and D value is 10. So that is 30. Then number of students who played only hockey, N of H minus B plus C plus D, again 50, 5 plus 10 plus 10, that is 25. And the number of students who played only volleyball, that is N of V minus A plus C plus D, that is 40. A value 10 plus 5 plus 10, that is 15. So now we got the number of students who played only cricket, those are 30. Number of students who played only hockey, those are 25. And number of students who played only volleyball, those are 15. Now next question is that in a group there were 115 people whose proofs of identity were being verified, and some had passport, some had over voter ID and some had both. Now if 65 had passport and 30 had both, how many had voter ID only and not the passport? Now whatever you have got, the information you can keep in your Venn diagram. So 65 total number of people 115, common both who have passport and voter ID, that is 30. Now passport and voter ID, either passport or voter ID is equal to N of P plus N of V minus N of P intersection V. Now both have passport and voter ID, that value is 30. So you have to keep here. Now N of P we have to find out. N of P we have here. They have given the N of P value. N of P is 65 and N of P union V, that value is also available, that is 115. Now after keeping these values, you will get the N of V is equal to 80. Now 80 is total number of people who have a voter ID. Now they are asking how many had voter ID only and not passport. That means it should not contain the passport. So definitely 30 people have both passport and a voter ID, and we got the total number of people who have voter ID, that is 80, and 30 number are there who has passport also and a voter ID also. So definitely 80 minus 30, that is 50. 50 people are there who have only voter ID but not passport. Now next example is that in a bank of 320 staffs, 120 speak in French, 140 speak English, 170 speak Arabic, 50 speak both French and English. Then 35 speak both English and Arabic, and 40 speak both French and Arabic. Now required, determine the number of staffs who speak all three languages. Total number of people, staff 320. Who are speaking French, that means N of F, that is 120. Who are speaking English, that is N of E 140. 170 speaking Arabic, so N of A is equal to 170. Now French and English, that is 50. Who are speaking French and English both, that is number 50. Who are speaking English and Arabic, 35. And who are speaking French and Arabic, that is 40. So now we have three sets. So according to that, we have to write the formula N of U is equal to N of F plus N of E plus N of A minus N of F intersection E minus N of F intersection A minus N of E intersection A plus N of E F intersection E intersection A. Now you have every value available. So 320, 120 plus 140 plus 170 minus 35 plus 40, and this value you have to find out. So we are keeping here as a x. After solving, you will get the value x is equal to 15, and x is a number of staffs who speaks all the three languages. All the three languages. Now next question is that out of 45 students, question 42 like mathematics or English or both. 27 students like maths, 22 students like English. Now you have to find out who didn't like any of the subject, who like maths only, and both maths and the English. Now, total number of students question, that is 45. Total number of students like either mathematics or the English, that is N of M union E, that is 45. Then total number of students who like mathematics, that is 27, and the number of students who like English, that is N of E, it's 22. Now the number of students didn't like any subject. So definitely we can use U of minus N of M intersection M union E, that is either case. So U is 45 and M intersection M union E is a 42, that is 3. That means 3 students are there who didn't like any subject. Now next case is that the number of students like both maths and the English. Again we will use the formula. Both maths and the English means we can say N of M intersection E. Again we can say N of M union E is equal to N of M plus N of E is minus N of M intersection E. Now 42, N of M value is 27 and N of E is 22. We have to find out N of M intersection E. After solving this formula, you will get the N of M intersection E, that is 7. That means 7 students are there who like both maths and the English. Now, who like maths only? So definitely who like maths means N of M minus N of M intersection E. N of M is 27 and the N of M intersection E, that is 7, that is 20. So 20 students are there who like only maths. Now next question is that a survey was conducted on the newspaper readership of 3 dailies: the Mirror, the Citizen and the Times. For Mirror we are using M, Citizen C and the Times T respectively. And the following data was obtained: the number of people who read Mirror, Citizen and the Times was found to be 55, 45 and 39 respectively. Now the number that read Mirror and the Times, that is 19. Number that read Citizen and Mirror, that is 15. Number that read Citizen and Time, that is 14. Now determine the number of people who read the Mirror only, who read the Citizen or Times but not the Mirror, and the total number of people interviewed if 5 people read none of the paper. Now here, this is your Venn diagram. In Venn diagram we are showing like a Mirror, Times and a Citizen. Now we have the information like that. N of M that is 55 means B plus C plus D plus E is equal to 55. Then N of C, that is 45. N of T, that is 39. Then N of M intersection T, that is 19. They have given number that read M and T, that is 19. Then number that read Citizen and Mirror, that is 15. Then number that read Citizen and Time, that is 14. And all 3, that is 4. So given that we know the value of E, we can solve the following. D is 19 minus 4, that is 15. C 11 and G, that is 14 minus 4. So using equation 1, we can find out the value for B. That is, B is equal to 55 minus 11 plus 15 plus 4, that is 15. Now next question is that each student in class of 40 plays at least one indoor game, chess, carom and Scrabble. 18 play chess, 20 play Scrabble and 27 play carom. 7 play chess and Scrabble, 12 play Scrabble and carom, and 4 play chess, carom and Scrabble. Now you have to find out the number of students who play chess and the carom, chess and carom but not the Scrabble. In first question there is no condition. You have to find out the number of the students who are playing chess and the carom. But in second problem they kept one of the condition, that is students are playing the chess and the carom but they should not play the Scrabble. So now we will consider the A be the set of the students who play the chess, B set of the student who play the Scrabble, and C who play the carom. Now therefore on this basis we have the information, that is each student in class of 40 plays at least one indoor game. So that means we can say N of A union B union C, that is 40. This is your either condition, either at least they are playing one game. Then N of A chess, that is 18. N of B Scrabble, that is 20. N of C, that means carom, that is 27. Then they have given the chess and the Scrabble 7. Then Scrabble and carom 12. And chess, carom and Scrabble, that is 4. Now we have the formula, that is N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A and plus N of A intersection B plus intersection C. Now you have to keep all the values in this formula and you will get the N of C intersection A value. Now that C intersection A value is 10. That means we can say that number of students who play chess and the carom are 10. But now this is the first problem. Now second is that students are playing chess and the carom but not the Scrabble. So definitely you have to subtract the condition, subtract the values. That means N of C intersection A minus N of A intersection B intersection C, that is 10 minus 4 is equal to 6. Now next question is that in a competition a school awarded medals in different categories. 36 medals in dance, 12 medals in dramatics and 18 medals in music. Now if these medals went to total of 45 persons and only 4 persons got medals in all 3 categories. Now how many received the medals in exactly 2 of these categories? Now let consider A be the set of the programs, a set of the persons who got medals in a dance. B set of the person who got medals in dramatics. And C set of the person who got medals in the music. Now given is that N of A is equal to 36, N of B is equal to 12, N of C is equal to 18. Now N of A union B union C, that is 45, and N of A intersection B intersection C, that is 4. Now we know that the number of elements belonging to exactly two of the three sets, that is ABC, is equal to n of A intersection B plus B intersection C plus A intersection C minus 3 of A intersection B intersection C. Now you have to keep 3 into n of A intersection B intersection C. Now n of A union B, A intersection B plus B intersection C plus A intersection C minus 3 into 4. Now this is your first equation. Now n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C. Now therefore, we can equate this formula. That means n of A intersection B plus B intersection C plus A intersection C is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C minus A of A union B union C. Now from first n of A plus n of B plus n of C, n of A intersection B intersection C minus n of A union B union C minus 12. Now you have to keep all the values, and after solving this, you will get the answer, that is 13. So our answer is 13. We got the who received the medals. Exactly 2 of these categories is 13. Now next question is that in a group of 100 persons, 72 people can speak English and 43 can speak French. How many can speak English only? How many can speak French only? And how many can speak both English and the French? Now let's consider A be the set of the people who speak English, B be the set of the people who speak French. Now A minus B be the set of people who speak English but not French. B minus A, set of the people who speak French but not English. And A intersection B means set of the people who speak both French and the English. Now given is that n of A is 72, n of B 43 and A union B is 100. Now A intersection B, again n of A intersection B is equal to n of A plus n of B minus n of A union B. Now n of A value is 72, n of B value is 43 and n of A union B is 100. After solving this, you will get answer, that is 15. Then again, number of persons who speak both French and English, that is 15. So now again we have to find out the n of A. N of A means again n of A minus B plus n of A intersection B. And n of A minus B means showing who speak English but not the French. And this thing we have to find out. N of A value is 72. N of A intersection A minus B plus n of A intersection B value is 15. That means 72 minus 15, that is 57. So we can say n of A minus B, that is 57. So it's showing set of the people who are speaking English but not the French. That number is that 57. Now n of B minus A we have to find out, and n of B minus A is showing that people who speak French but not the English. So n of B value is 43 and n of A intersection B is 15. So 43 minus 15, that is 28. So number of people speaking French only is 28. Now next question is that there are 35 students in art class. 57 students in dance class and find the number of students who are either in art class or in the dance class. When two classes meet at different hours, 12 students are enrolled in both activities. And when two classes meet at the same hour. Now, N of A is 35, N of B is 57. And for both, it's showing 12. N of A intersection B, that is 12. So, we can say as A be the set of the students in the art class and B be the students in the dance class. Now, first question is that when two classes meet at different hours. So, N of A intersection A union B, N of A plus N of B minus N of A intersection B. That is N of A value 35, N of B is 57 and that is 12. So, after solving you will get the A union B, that is 80. Then when two classes meet at same hour, this is not A union B. So, N of A plus N of B minus N of A intersection B. So, definitely this thing will cut and you will get the N of A plus N of B. And N of A value is 35 and N of B is 57. So, these are the 92. Now, next question is that in a group of 60 people, 27 like cold drinks, 42 like hot drinks, and each person like at least one of the two drinks. Now, how many like both coffee and tea? Now, let's say A be the set of the people who like cold drinks and B be the who like hot drinks. Now, A of A union B, that is 60. N of A, that is 27. N of B, that is 42. So, definitely again we have the formula A intersection B is equal to N of A plus N of B minus N of A union B. So, N of A value is 27, N of B value is 42 and intersection is 60. So, after solving you will get the answer 9. That means people who like both tea and coffee, 9. So, these are the references. This is all about the set theory. You can go through these references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.